Okay, so we are now talking about the critical path and how to calculate it, how to find the critical path manually by hand. This is what's known as the critical path method, and we've already defined a few terms: forward pass, backward pass, free float, and total float. Now, get your cup of coffee ready. This is going to be a long one and a detailed one, but you're going to come out with a lot of good information here. So let's define an example first. In this example, I have a table in front of you here that lists activities A through G. For each activity, we also list the predecessor. So for each activity, we're going to say, for example, activity B. The predecessor to activity B is activity A. So essentially, this is called sequencing activities. Activity B comes after activity A. Same for activity F. It comes after activity B and C. The predecessor to activity F is B and C. And we define for each activity the same. We also define for each activity a duration. My duration here is in weeks. I didn't put the units, I just put the numbers just to keep the screen a little simple here, a little minimal. Activity A has a duration of 1 week. Activity D has a duration of 7 weeks. F has 2 weeks, so on and so forth. This is our example. And what we're going to do is we're going to take this data and calculate the critical path. Can you look at this data right now and identify what the critical path is? Is it A, C, F, G? Is it A, D, E, F? What is the critical path? That's what we're going to calculate through the critical path method. So first things first, I need to draw a network diagram representing this information. Representing more specifically the sequencing of the activities. So I'm going to use the activity column and the predecessor column to draw a network diagram. Now it's going to take a second to draw it out here. It's part of my fancy animations. But in the meantime, while it's doing that, at the top right there, you'll see that I've included our example with activity, predecessor, and duration columns up there, just so that we can reference it through the slides as we go along. And this is how I've drawn my network diagram. I started with activity A all the way on the left. And I said, okay, next activity, activity A doesn't have a predecessor, right? It's the first activity. Next activity, which is activity B, has a predecessor of A. So all I do is I draw an arrow that stems from A to B. C has a predecessor of A as well, and so does D. So I put C at the top, D at the bottom, and I drew arrows to them. Now keep in mind something important with network diagrams. Your lines should never cross. Your lines should never cross. Activity E. The predecessor to E is activities B and D. So I draw 2 arrows, one from B, one from D, into E. The same for F. The predecessor for F is B and C. And finally, activity G, the predecessors for that are E and F. And I draw my arrows and off we go. Very, very nice and simple. I drew a network diagram, right? Nice and easy so far. Now we're going to get a little more complicated. Now, what I need to do is start defining my early start and early finish dates, my late start, early, late finish dates, and my floats. And we're going to take it step by step. We're going to do a forward pass first, then a backwards pass, and then a float. Once we calculate all of that, then we can figure out our critical path. And through the critical path method, to help you define these passes and the floats, is this diagram that you see here. It's essentially a box that says, okay, here's how you're going to lay it out. At the dead center, you're going to put your activity. So activity A, B, C, whatever it is. Above that, you're going to list the duration of that activity. To the left and right of the duration, you're going to list your early start and early finish. So ES and EF, that's how they're denoted. And at the bottom left and bottom right, you're going to put your late start and late finish. In the center, you're going to put your float. Now, to calculate your forward pass, you're going to use the formula early finish is equal to early start plus duration. I've denoted here as EF equal ES plus D. Your backwards pass is going to be your late start is equal to late finish minus the duration. And your float is going to be one of two things, either your late start minus your early start, or your late finish minus your early finish. And if you've done your forward and backward passes correctly, then it won't matter which one of those two formulas you use for float, they'll give you the same answer. If they give you different answers, you've done something wrong. So keep in mind this box that I have up here because it's going to guide you along the way. So let's start. This one animated a lot quicker. On the next slide here that you see, at the top right, I've included our example from the very beginning, the table that we have listed. I've also included the guide that we're going to use. And I'm going to start in a very, very simple way by identifying my activities and durations. So I took my network diagram that I drew, and I just expanded it to replicate that same template as the guide. You'll see that I have a spot for duration and float and late finish, early start, etc. And all I've defined is activity A has a duration of 1, and I put the 1 where the duration should sit. Activity F has a duration of 2. E has a duration of 5, so on and so forth. Nice and easy. Nothing complicated so far. Once I've done that, I can do my forward pass. So now pay attention here. My forward pass uses the formula early finish is equal to early start plus duration. Okay, so I start with task A. Task A is the first task of my project, which means that its early start, which sits at the top left corner, is 0. I'm going to use my cursor to point here. My early start, which sits over here, is 0 because it's the first task of my project. It's the first activity of my project. 0 day start, basically. And it says, okay, we've included a 0. The formula says early start plus duration. So 0 plus 1 gives me 1, which is my early finish. Next, let me move into task B. Now, task B has a predecessor of A. So what I do is I take the early finish of task A, and that becomes the early start of task B. Now notice something important. Task C also has a predecessor of A. Task D also has a predecessor of A, so the same applies to all three tasks. The early finish of A becomes the early start of C, the early start of B, and the early start of D. 1, 1, 1. And then I carry on with my formula. 1 plus 3 is 4. 1 plus 4 is 5. 1 plus 7 is 8. I've calculated the early finish dates for tasks C, B, and D. I hope you're following so far. Nice and easy. Next, let's get into task E. Now we get a little trickier. Task E has a predecessor of B and D. Now, B has an early finish date of 5 weeks, and D has an early finish date of 8 weeks. How do I know which early finish date to use? When you're doing a forward pass, you take the larger of the two numbers. So I'm going to take the 8 and slot it into the early start date of E. 8 plus 5 is 13. Same for F. The predecessors to F are C and B. Which one do I use? I take the larger of the two numbers because we're doing a forward pass, and it becomes the early start, which is 5. 5 is larger than 4. 5 plus 2 is 7. And again, for task G or activity G, I take the larger of the two numbers. 13 is larger than 7. 13 becomes my early start date for G. 13 plus 1 is 14. 14 is my early finish date for activity G. Through this forward pass, a very, very basic formula, we've calculated for each task what's the earliest date I can start it and what's the earliest date I can finish it. That was a forward pass. Now we do a backwards pass, quick animations. We start from the end and we work our way backwards. And we use a similar formula, but reversed. The formula says, you're going to calculate the late start date by taking the late finish date minus the duration. Now, because we're starting at the end, my early finish date, which is 14, by default becomes my late finish date. They are the same. So to calculate my late start, I will do late finish, which is 14, minus the duration, which is 1. That gives me a late start of 13 weeks. Now, we move backwards. The late start date of G, I'm going to move into F here, becomes the late finish date of F. Similar to what we did in the backwards pass, just reversed. In the forwards pass, just reversed. I apologize. So F now gets a late finish date of 13. 13 minus 2 gives me 11. Same thing here. Task E, because it's a predecessor to G, it inherits that late start date as its late finish date. 13 minus 5 is 8. Okay, now let's keep moving. Here I have task D. I'm going to start with D here. Task D inherits the late start date of task E, as its late finish date. So 8 minus 7 is 1. The same happens for task C, activity C. It inherits its late finish date here as 11. 11 minus 3 is 8. But what about task B? You see, task B is a predecessor to F and E. So should it inherit the 11 or the 8? Remember, with the forward pass, we said you're going to take the larger of the numbers and move it forward. With the backwards pass, you're going to do the opposite. You're going to take the smaller of the numbers and move it backwards. So 8 is smaller than 11. 8 becomes my late finish for task B. 8 minus 4 is 4. And we do the same thing again for task A. I have 1, 4, and 8. Which one do I choose? 1. It's the smallest number. It becomes my late finish date for task A or activity A. I use task and activity interchangeably here. 1 minus 1 is 0. Nice and easy so far, I hope. That is called a backwards pass. So we went forward, calculated early start, early finish, and we went backwards, we calculated late start, late finish. The latest date that an activity can start and the latest date that an activity can finish. Right, we're doing well so far. Next, what we're going to do is calculate float. Now, I told you with float, there's two formulas. It doesn't matter which one you use. Late start minus early start or late finish minus early finish. So we start with task A. Let's do both. Late start minus early start, which is just above each other here. 0 minus 0 is 0. Or we can do 1 minus 1, which is late finish minus early finish, is 0. Let's do task B. Late start minus early start is 4 minus 1. That's 3. Late finish minus early finish, 8 minus 5. That's also 3. So we get our 3 here to put it in place of float. Same for task C. 8 minus 1 or 11 minus 4 will give you 7. Task D. 1 minus 1 or 8 minus 8 will give you 0. And again, you get 6. 0 for task E and 0 for task G. I hope you can see that if you're getting different numbers between the late start minus early start or late finish minus early finish, you've done something wrong in your passes, right? It doesn't matter which one you use, you enter your float over here and it should result in the same number. Okay, so now we've calculated our float. Our float is the amount of free time we have for that activity to delay a little bit. From our float, we can use this to develop our critical path, to identify our critical path. And the critical path essentially is the path through which any activity has a float of 0. It's the longest path through my project through which any activity that gets delayed will delay the entire project. To put this into action, think about it. If activity D has a float of 0, if I delay activity D by 1 day, what's going to happen? It's going to delay the entire project because it doesn't have a float. It's a float of 0. So here, Using this example, I can say that any activity with a float of 0 forms part of my critical path. So my critical path becomes A, D, E, and G. And you list it like this. You can even calculate the duration for your critical path. A has a duration of 1, D has a duration of 7, E has a duration of 5, and G has a duration of 1. Putting that all together, you get a duration of 14 weeks. You can say that your critical path is ADEG, and you have a total duration of 14 weeks on your critical path. It's a bit of an involved method, but it's easy. I hope you can see that the calculations are very, very easy. You can do this in project management software. You can simply hit show me the critical path and it'll do that for you. It'll highlight it for you in red or whatever color, and it'll show you right away. But it is a crucial skill for any project manager to know how to calculate the critical path by hand through the critical path method. One last thing I want to talk about in terms of schedule is compressing the schedule. There's two typical ways of doing that when you want to move things a little faster. You can do what's known as crashing. And crashing is essentially when you start speeding up activities on the critical path. Hey, activity B, let's do that in a shorter time. I know the duration is 7 weeks, but let's put more resources on it. Let's put more money into it. Let's do it in 5 weeks. That is called crashing an activity, crashing the schedule. And it costs you a bit, right? Remember, project constraints. You can also do what's known as fast tracking. Fast tracking is when you run things simultaneously, run things in parallel. Now, you're going to have to pay attention to your dependencies here a little bit, but you can say, for example, okay, you know what? I can actually do task D while I'm doing task B. Let's just do them together and get them done. That is called fast tracking instead of doing them separately. But you need to pay attention to your dependencies, because if task D cannot start until task B has finished, then you can't do that. You need to parallel your activities carefully. Right. We're going to stop it here because we talked about a lot with regards to schedule management, and we broke down the critical path method into fine details of how to do it by hand. It's a really, really valuable skill. If you need more practice, I do suggest that you revisit this recording again to fully understand how to calculate the critical path. It is really, really crucial. All right, we'll stop it here. I'll see you on the next one.